In this video, we're going to be looking at some of the homework problems in section 14.2, which deals with the Pythagorean theorem, the equation of a circle, and the distance formula. And here's problem number 1. In a right triangle, you're going to find the lengths of the sides not given. We know that A is equal to 6 and C is equal to 10. Here's A, and I marked it off as 6, and C is equal to 10. Now here this figure is not drawn to scale. Okay, and we're trying to find out what the length B is going to be. Here we're going to use the Pythagorean theorem for this situation. Okay, and I've already written down A is equal to 6 and C is equal to 10. Now the formula for the Pythagorean theorem is this. That's A squared plus B squared is equal to C squared. In other words, the square of the hypotenuse, which is C, and that's equal to the sum of the squares of the lengths of the other two legs, A and B. I know what A is, that's 6, so I replace the A with 6, so that'll be 6 squared, plus B is what I'm trying to find, so that's B squared is equal to C, which is 10, that's going to be squared. Okay, now square the 6, that's 6 times 6, that's 36, plus B squared equal C, or 10 squared, 10 times 10, that's 100. Now to get B squared by itself, I'm adding 36, so I'm going to subtract 36 from both sides. So now B squared is equal to 36 from 100, that's 64. And then to get the B by itself, we're squaring B. We need to take the square root on both sides, because the opposite of squaring something will be taking its square root. So here, B is equal to the square root of 64, that's 8. So the length of B in this particular situation here, or the length of this third side, is 8. Okay, so that's the length of that missing side B, which is 8. Okay, now let's look at the next problem. Now here we want to determine whether the given numbers represent the lengths of the sides of a right triangle. In this case, 3, 4, 5. Okay, now in this case, this is where we're going to use the Pythagorean theorem, which is of course A squared plus B squared is equal to C squared. The 3, 4, and the 5. The C is the longest side, which is going to be the 5. The 3 and the 4 are going to be my legs here. So I'm going to replace the A with 3. So that'll be 3 squared plus B is 4. 4 squared is equal to C. That's 5 squared. So 3 squared, or 3 times 3 is 9. Plus 4 squared, which is 4 times 4, that's 16. And that should equal to 5 squared, or 5 times 5, which is 25. Well, if you add 9 and 16 together, you're going to get 25, which does equal to 25. Okay? And since both sides of this equation are equal to each other, that means that the 3, 4, 5 measurements represent the lengths of a right triangle. So in this case, we'll select yes as the answer. Okay, here's the next problem. A 16-foot ladder is placed against a vertical wall on a building with the bottom of the ladder standing on level ground, which is 9 feet from the base of the building. How high up the wall does the ladder reach? Sometimes it does help to draw a picture of this particular situation here. So here's what it looks like pictorially. Okay, here's a vertical wall of a building. And here's a 16-foot ladder. And it's placed against that vertical wall. And then the bottom of this ladder is on level ground. So from here to here, that's 9 feet. Okay, so we want to find out how high up this wall does the ladder reach. So we're finding this distance here, which I'm going to call B. I'm going to let A be 9, since I'm using the Pythagorean Theorem. Okay, so here, let's see, A squared plus B squared is equal to C squared. A squared plus B squared equal C squared. So in this case here, the A, I'm letting A be 9 feet. So that's 9 squared. Plus the B is what we're trying to find, so that's B squared, equal to C. This is your hypotenuse right here. That ladder is going to be your hypotenuse here, 16. So that's 16 squared. Now, square the 9, you're going to get 81, plus B squared is equal to 16 squared is 16 times 16, or 256. And then to get the B squared by itself, we subtract 81 on both sides. To get B squared is equal to, this is 5, 175. Yeah, 175. So B squared is equal to 175. Now, to find out what B is, we take the square root of 175, because the opposite of squaring something is taking the square root. So if we take the square root of 175 using our calculator, you're going to get, now to the nearest hundred, it will be 13.23. Okay. Because in the answer, they want this to the nearest hundredth, or 2 decimal places. So it'll be 13.23 feet. Okay, so to answer that question, the ladder reaches 13.23 feet up the wall. So in some cases, this is how you'll have to set up that particular problem. Sometimes drawing a picture does help. All right, problem number 4. Find the height of the tree shown to the right. So here's the height that we're trying to find here. We know this is 37. That's your hypotenuse, one of your legs, from a point on the ground to the base of the tree. That's 24 feet. So again, we're going to use the Pythagorean Theorem to solve this particular problem. Okay, and now I'm going to let this be B, which is the missing side that we're trying to find. And they do say round to the nearest tenth, if need be. So in this case here, using the Pythagorean Theorem again, A squared plus B squared is equal to C squared. Now in this case here, I'm letting A be 24 feet. So that's going to be 24 squared. The B is what we're trying to find here. So that's plus B squared is equal to C. Your hypotenuse is 37. And that's squared. Okay, so now 24 squared is 576. Plus B squared is equal to 37 squared, or 37 times 37. That's 1,369. Okay, so now, to get that B squared by itself, we need to subtract 576 on both sides of this equation. So now B squared is going to be equal to 1369 minus 576. That will give you 793. So B squared is equal to 793. And then it'll get the B by itself. You take the square root of 793. So now B is equal to, let's see, square root 793. That will give you, to the nearest tenth, 28.2. and it'll be approximately 28.2 feet. So to answer that question here, the length of the tree is approximately 28.2 feet. Okay, so that's how we use the Pythagorean theorem for these types of application problems. Okay, problem number 5 deals with the equation of a circle. And here you want to find the equation of a circle having the given center and radius. Here the center of this particular circle is -3, 6, and the radius is the square root of 7. Okay, if you would, well, here the formula for finding the equation of a circle given the radius and the center is this: x minus h quantity square plus y minus k quantity square is equal to r square. And in this case here, the center is -3, 6, which means h is -3 and k is 6. The center of the circle is always in the ordered pair h, k. H is your x coordinate, k is your y coordinate. And the radius, and I'm just going to say r, is the square root of 7. So using that formula, I'm just going to replace the h and the k, because the formula for the equation of the circle always has x and y in it. So here we bring down the x minus h is -3, so it'll be x minus -3, that quantity is squared, plus y minus k, in this case that's 6, and that's going to be squared, is equal to r squared. Well, r is the square root of 7, so the square root of 7 will be squared. Now let's simplify this. X minus a -3 is just simply x plus 3. So it'll be x plus 3 quantity squared plus y minus 6 quantity squared. And then that's equal to, now if you take the square root of a number and you turn around and square it, it's going to be the number underneath the radical. So the square root of 7 and u squared will just be 7. And that will be as far as I can go with that problem. Because in this case here, this is the equation of the circle with the radius of the square root of 7, and the center is at -3, 6. X plus 3 quantity squared plus y minus 6 quantity squared equal to 7. And you're given a choice of answers here, so it'll have to be the first one. Okay, here's another example. This one deals with a circle, but this time you're going to find the center and the radius of that circle. Here you got x minus 7 quantity squared plus y plus 2 quantity squared is equal to 70. Okay, so here we need to know what standard form is. X minus h quantity squared plus y minus k quantity squared, that's equal to r squared. The center is always h and k. And I'll rewrite the equation that we're dealing with. Okay, you have to look at the standard form here. For us to have a minus 7, the 7 had to be positive, so the h is 7. And for this 2 to be a plus 2, that 2 had to be negative because of the form y minus k. And we came up with y plus 2. For us to get y plus 2, that 2 had to be negative. Or you can think of this. Look at those numbers and just take the opposite sign. That would be h and k. So the center is 7, -2. Now for the radius. R squared is this number. That's 70. So to find out what r is, you're going to take the square root of that. And we're going to leave this as the square root of 70. Okay, because they want us to type in the exact answer. So the radius here is the square root of 70. And the center is simply 7, negative 2. Okay. Problem number 7. Determine whether the given numbers represent the lengths of the sides of a right triangle. In this case here, we got 3, 4, 5. And earlier we did a problem just like that, so I just answer that as yes, because that's one of our Pythagorean relationships, 3, 4, 5. And then number 8. A slow pitch softball diamond is actually a square 62 foot on a side. So here this is 62 feet. It's square. Each side is 62 feet. How far is it from home to second base? Here's home plate. That's second base. Okay. So here we can use the Pythagorean relationship here to find out what that answer is going to be. Because this is 62. This is also 62. And here we're finding the longest side. That's the hypotenuse. If I cover this up, I will have a right triangle. Legs are 62 feet each. And I want to find out what the hypotenuse is. Okay, so in this case here, this is where we use a squared plus b squared is equal to c squared. Or you can write this as c squared is equal to a squared plus b squared. Either way, it's the same thing. So here c squared is equal to 62 squared plus another 62 squared, because it is a square baseball diamond. 62 squared is 3,844. Plus another 3,844. So if we add that, you're going to get 7,688. So c squared is equal to 7,688. Now to find out what c is, which is the longest side, we're going to take the square root of 7,688. And to the nearest tenth is going to be, now I hope I'm right, to the nearest tenth, that will be approximately 87.7. Okay, so that's the distance from home plate to second base. Okay, so that distance is 87.7 feet. Okay, so that should be enough to assist you with some of the problems or the homework problems in section 14.2.